Thank you, thank you. It's always great to start with an applause because we had such an amazing presenter here, which is always lovely. So glad to see so many people here in Bern today. Great views, by the way. I don't think I've ever had such an amazing view behind me or like around me in a conference. That's great. But yeah. Let's get started. So, how Kubernetes optimization can combat climate change. A big topic, maybe a bit of a trendy topic, and hopefully we can kind of dive deep today. And, well, not dive deep, we're going to have an overview and learn more about the topic. A bit about me before we start so that you know who is babbling on here to you. So I'm CMO at Vision. So Vision is a DevOps as a service, DevOps enabler company from Zurich that provides both professional services around Kubernetes, Cloud Native, OpenShift, as well as has a host of really cool tooling such as Apuyo or open source tooling such as Keda under its wing. So there's a lot of cool stuff there. And this is the only time when I will now mention Vision, the last time for this talk. But I can tell you that we are raffling out a amazing Lego at our booth at the other location there up the hill. So if you're interested in that, hop on there and enter the raffle. But that's enough about that. So I'm also a CNCF ambassador as well as an Azure MVP. And if you're wondering what these two things mean, or like what are these weird letters here, it essentially just means that I'm super passionate about all things Kubernetes, Cloud Native, and all in between there. And I love talking about these topics for audiences such as yourself or in other conferences as well. I'm also a Kubernetes and CNCF meetup co-organizer since 2017 for Finland. I'm from Finland originally, but I have lived in Zurich now for 2 years, so now I help out with the Swiss meetups as well. And if you're ever planning to join those, happy to see you there as well, of course. I also coach early stage startup, as well as I co-host a podcast called Cloud Gossip. I'm also been co-hosting the CNCF Live, so Cloud Native Live, which is a weekly live stream by CNCF for 1.5 years now, as well as I've been frequently in the KubeCon program committee as well. But that's enough about me. Let's go more to the topic. So what will you learn here today? We're going to learn more about green software, sustainable Kubernetes, and all of these kind of fun topics. And hopefully we're going to kind of have a good overview of all of these topics so that you know if you want to dive deeper into any area of this topic, that you can do it then on your own. So that's the goal today, to maybe spark interest into these topics from your side and give you the tools to dive deeper yourself. And here is a bit of a more clear agenda. So we have the introduction, which is already ongoing. We're well on our way there. We have the principles of green software as well coming up. Then we have the principles in practice, which is Microservices example. And then we're going to go through an open source project called Keda to just show you a bit more in practice on how things can work. And then I'm going to give you some resources at the end. But let's dive in. So I think in general, the world has come into a place where people care about sustainability in their private lives quite often. Who here considers sustainability or green topics on their like personal life on a often basis? Yeah, pretty much everyone considers them. But what about professionally? Do you think at work on am I making sustainable choices in your work life? Who considers these things at work? Few hands, but a lot less, I think, than the first one. So that is definitely, I think, this is where the scene is currently, that we think about, okay, should we fly less or so forth, but then we might not think about, okay, what is our professional life, what is the impact there? And because also working in technology, I will let you in on a secret, or not so known secret to be other, not such a secret, more of a well-known fact, essentially, is that actually tech is a huge polluter. So software-related emissions account for 45% of global emissions. So it's equivalent to all of the emissions of aviation, shipping, and rail combined. So combined. So if you think about tech as an industry, we're very much at the forefront, I guess, in a negative way, towards these topics. So it definitely, I think, as technology industry people, tech people, we have to consider these topics actually quite urgently in a way. And probably the number is just going up and up because the numbers are always obviously lagging behind because we get only data usually afterwards. So it's only going up as we go. And why is that? Because of modern technologies, which are, by the way, great. I have other sessions where I'm all about like machine learning, AI. They're really great services and they have their place and they are really needed as well. But modern technologies do require more and more compute power, and that's just a simple fact. So with the advent of AI, machine learning, all of these topics, we need more compute, aka we'll be using more resources as well, which is unfortunate in that case. And then kind of the topic of this today is essentially that if we don't check these in, the world is going to go through irreversible changes if climate change remains unchecked. It depends obviously on what level exactly will it happen and so forth, and there's debate from scientists there, but that is the reality that we are facing, that we are changing the environment where we live in a way that we can't take back as well. Now, okay, someone might be thinking, okay, what does Kubernetes have to do with things? Okay, technology affects these things, but what about Kubernetes? So this is from the CNCF survey from, I think, a year and a half ago or so. So Kubernetes is very much the backbone of the global technology infrastructure nowadays and the cloud native world. So you can see 96% of organizations are either using or evaluating using Kubernetes. So it's definitely, if we can nudge Kubernetes usage, or Kubernetes itself, obviously as well, into a more sustainable path, into a more sustainable configuration and usage, we can really have an impact to the world of technology, and therefore we can have an impact to the emissions in a global level. You saw that percentages there. So that's essentially why I'm talking about Kubernetes or cloud native as well. And now, worry not, you can actually, essentially, if you do any Kubernetes configuration best practices, you don't just use it out of the box or, without thinking about it, you're probably already doing something that's likely benefiting the situation in a way, because any sort of configuration for best optimization, cost optimization, all these things are likely going to have some type of positive impact to your usage so that you are not wasting as many resources. Now, obviously, then going more granular and actually impacting in a more specific way and actually in a intentional way is always the best. But, there's a lot of best practices that you can use from the general, Kubernetes. This is from the Kubernetes docs as well. So there's a lot of things there. A few considerations before we kind of go more into what is green software, what is Kubernetes recommendations and examples and so forth. This industry, aka green software space, is constantly evolving. So if I say something here today, it might happen that in a half a year, some new research comes out that modifies it a bit or new tooling comes available. I think that's amazing, but I do have to say that the change of the pace of the change is huge. So there is constantly new things updated. Like sometimes done this session within 2 months apart from it, like a new version of it, and then I've had to update 1/3 of my slides because they were all kind of outdated at that point to an extent, like just fiddling around with it. So there's always going to be kind of changing this, particularly now since the industry is so new on how things work and so forth. And another point is be aware of greenwashing. This is a big topic in general, but today I'm not going to focus on too much on this. So obviously validate things on your own, think about what are the effects for your environment, for your setup, as well as think about are some things maybe promised to you as far as greenwashing goes that are maybe too good to be true and so forth. So think about that. But I'll give a resource in the end if you're more interested on like a deep dive, 30-minute, 45-minute on purely just greenwashing topics. Today I'm going to keep it a bit more light and we're not going to go to that dark side of the industry in that way. But I recommend highly on actually checking there as well deeper. So then we're going to talk a bit about the principles of green software. So who here is familiar with the Green Software Foundation? One hand, I think. 2 hands, 3. You were a bit shy there, but that's fine. But 3 hands maybe. So that's cool. Then everyone's going to learn new things. I actually love that. It's like if everyone raised their hand, I wouldn't have much to do here. You would all know everything already. So that's really great. So Green Software Foundation is a foundation underneath Linux Foundation. So it's open source, it's non-profit and so forth. And the Green Software Foundation's mission, as you can see here, is to build trusted ecosystem of people, standards, and tooling and best practices for green software. So they have so many resources that you can deep dive in to as well. So I highly recommend checking out there. They have a podcast, YouTube, blog posts, so many things as well. And they have developed a lot of tooling that's starting to become or has become the industry standard on how do we evaluate green software or the sustainability or the harmful impact on these terms for Kubernetes cloud native green software to begin with. Because before that we can start optimizing or we can think about how to improve your compute, we actually have to understand what is the impact of your compute. Because if you start just optimizing without knowing what are you optimizing or why are you optimizing or what is the parameter that you're measuring against, how would you know are your actions actually having a positive impact or not? So you do have to first develop the standards on, okay, how do we measure the impact? And then you have to be able to measure your impact, and then you can start kind of making a change to that impact as well. So some of the principles are here. So these are going to be a list that's kind of like, you're going to be like, okay, that's cool. That sounds simple, but it's much more complex than that. I understand that. But essentially, carbon, build applications that are carbon efficient, check, carbon efficient, perfect. Obviously, not that easy. Electricity, build applications that are energy efficient. Carbon intensity, consume electricity with the lowest carbon intensity. So it's about carbon efficiency, energy efficiency, and then lowest carbon intensity. Then we have embodied carbon, which is build applications that are hardware efficient. So embodied carbon means, for example, my laptop, there has to be have used resources to get this laptop out there as well. So if I measure my compute, I have to consider the machines, both in the data centers or in my on-prem cloud or whatnot, or the machines that I use to do the development as well. Energy proportionality, so maximize the energy efficiency of that hardware, for example. And networking, reduce the amount of data and distance it must travel across the network. Demand shaping, build carbon-aware applications, a bit more on this and all of these. And measurement and optimization. So focus on step-by-step optimizations that increase the overall carbon efficiency. So that is the list. I could just, end the talk here and be like, follow this list, you'll be done. As I said, not as easy as that, obviously. It's all very vague and high level there. And if that was too much as far as the list goes, we can really focus on these. Carbon efficiencies will have the biggest impact in terms of your action, essentially. So energy efficiency, hardware efficiency, and carbon awareness can essentially all be put into the basket of carbon efficiency. Well, what that does then kind of mean more in practice, and how can you kind of affect these things? Well, energy is at the heart of everything. So what electricity runs in your grid, so that is usually where it starts from. So if you're running your compute in a data center that uses a certain type of energy, so coal versus wind energy versus solar or nuclear and so forth, that is one of the biggest contributions to your impact to the world on this sense. And now it differs hugely on location to location. What are the impacts there? So for example, Nordics have a lot of renewable energy. Switzerland has a lot of nuclear energy, as well as France, for example. But Australia, for example, has a lot of coal energy. And obviously, it is not that it's a simplified sentence to say da 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 da, but these are the things that you have to think about, because how green or how clean the energy grid is, that is a huge impact. And then you can really get into location shifting, which is one of the principles as well, or like the things that the building blocks of building efficient applications in this sense. So the intensity of the electricity differs by location greatly, as I said there. Some grids are really better than other. And a good example of this in practice, for example, was that Google did an experiment where they shifted between locations, so they used obviously their own cloud, and they shifted between locations for their data centers, their compute, and then they saw a reduction of 1%. And when I say 1%, you might be thinking, oh, that sounds small. But if you think about the scale of Google's whole compute and what all of their services, for example, use, we're talking about really good number as far as reduction goes. And for them, they actually didn't even do for that experiment. They didn't switch between countries. They simply switched between, locations within a state or a city, for example. So you don't even have to skip from, Europe to America or so forth, because there's already differences there as far as US East Coast and West Coast and so forth. So here is the best resource that I can find for like grid cleanness in general, which is out here, this one. So you can see that there's locations, even within US, there's a huge difference between, we can see the green is green energy or like better, clean energy, and then the black is the harmful that we would like to avoid. So there is a lot of different areas with different variations. So you can have a huge impact simply by, moving around a bit, everything. Another big one is time shifting. So location shifting was there, and then we have time shifting. So this is about, shifting the time when you're using applications. So when clean energy might be available or might not be available. So it is a well-known paradox in this sense that, for example, during the day you have, for example, solar energy available because the sun is up, we have sun and so forth. But then most of the, for example, consumer electricity usage might go to the evening time when people might be switching on their TVs, enjoying their primetime TV shows or whatnot. So then actually energy peaks, but the renewable energy sources go down. So what does this then mean for technology or developing, investing and so forth? Well, you can think about running your software where the carbon intensity is low. So this is the key. So if you switch, for example, batch job to run at 1 in the morning instead of during the peak hours for consumer usage, the electricity grid intensity is going to be much lower. And this doesn't even have to be like drastic changes. By just optimizing for 1 hour, you're going to see huge benefits there. And Windows, Microsoft has done this, so they have carbon aware updating of Windows and whatnot, and that already has a huge impact because you can think about the scale of Windows as well on how that affects if you actually optimize there a bit on how things work. Another principle is demand shaping. So for here, I actually have a nice example. Now, the two ones before this were actually things I think that everyone can kind of implement to an extent in their work. Demand shaping might be a bit trickier to consider, to think about. But let's see, this is an example. So this is Branch, which is a magazine that's a sustainability magazine. So they have this snazzy looking nice website, and you can see that this image here, it's grayscale because we can see grid intensity here. So it's live. So it's grayscale because we are at, we need that because when you put it on low grid intensity, we get colors. So it's shaping the demand by the demand on how much it will use, because having the colors will obviously require more from the grid. So if we then put it high, there's no images at all. So when the energy grid intensity is high, it takes away the images. If it's low, it has color. And if it is moderate, so in between, it is grayscale. And now when I said that this is not doable for all applications, everyone can kind of think like, okay, yeah, you can't just have banking applications that are just not usable at certain time or doesn't have some type of images or visuals, obviously. But there might be proportions or whatnot. And for example, for this magazine, it makes sense. And I think the image, for example, here works quite okay in grayscale as well. But this is, I think, like a very highlighted example of them using this. And now we go back to live. So every time you visit the site, it might look different depending on what the grid intensity is there. Perfect. Then let's get back there. And they have an example of their previous cover there from with a lot of colors. So then we have increasing utilization. So when you have that hardware, you should make most out of it. So instead of using multiple resources with no optimal utilization, it really works the best when you use less resources and then actually use them efficiently. So this is obviously a crude image. It might not be possible always to be at 100%, but it's better to be closer to that than using more the second image there. And this is, for example, a key area where Kubernetes can help. Now, I mentioned the importance of being able to measure and track and metrify your impact to the world in this sense. Well, this is a software carbon intensity, SCI, which is a project from Green Software Foundation, which is the specification for measuring that. So this is how it looks like. So it's a simple mathematical equation that can be used to calculate your impact. I have here that you can do a deep dive because it's an open source principle foundation, so you can find all the different calculations and how do this work, why are these the different portions there, and how to arrive at your own result and so forth. I'm not going to do a deep dive there because I could probably do an hour just on using this tool, but you can check it out from there as well, and I'll give the link in the end as well. So that is the principles in theory level, kind of. But then if you're now wondering, okay, what can I actually do? Like, what are the things that I could be considering doing in my job? Well, then I have a few different microservice examples that you can kind of think about using here. So on a high level, it's optimize network traffic, increase your compute utilization, reduce your number of microservices, optimize your database, and understand your latency limitations. Now again, it's like, okay, just optimize your database, all easy. But let's actually deep dive a bit more into these topics. So optimizing your network traffic, what does that then, for example, means for you? You should think about your traffic and architecture. So reduce the amount of traffic your architecture creates per operation, as well as the distance each request and response travels. Then you should also consider using caching headers because caching static assets at the browser or proxy level allows future requests for those assets to be handled by those caches and reduces network traffic for your application as well. So you should consider using a content delivery network as well, because it reduces, again, the distance all requests for those static assets that they have to travel over the network. You can think about reducing the size and optimize your bundles and static assets as well. And then using compression and decompression of data as well, because it usually takes less overall energy to decompress and compress than to transmit uncompressed data over the network. A bit more on these best practices to think about. And again, it's my favorite thing in IT is to say it depends, because you never know what's best for your environment. But these are some of the general tips that I can give. So increasing your compute utilization. So update your workload, distribution and compute resources. So use less resources at a higher utilization. I mentioned this already. So this reduces the amount of energy your compute resources spend in an idle state, for example. Using smaller virtual machines, so you get closer to that 100 rather than actually not using 30% of all bigger ones. Platform as a service might be a good option to consider from the get-go. It might not always be the best option, obviously, but usually platform as a service services are adequately, appropriately sized for their workloads, so that might already help from the get-go. Using autoscaling or burst capabilities so that your capabilities allow you to increase and decrease as you need it. And I have a demo about this coming up later. Using physical tiers and logical layers as well. So increasing your physical tiers and reorganizing where your logical layers run as well. So then we also have reduced the number of microservices. So what does that mean in practice then? So just having a microservices architecture is already kind of good. It's an effective way to focus your services around a specific thing, and it also should help limit network congestion, latency, as well as overall complexity. So there's a lot of things that you can think about there from the get-go. You can combine services logically or physically, where similar scale points exist to reduce the footprint of overall architecture as well. And if you have two or more microservices that are highly coupled, consider co-locating them to reduce the network congestion and latency. And then use regions with lower carbon intensity. And that obviously we went through with the location shifting as well already. And then use languages and technology stacks that optimize the efficiency of a specific microservices function. So how does that then look like a bit more in practice? Well, here is this study, energy efficiency across programming languages. How many has heard or seen this one? Yeah, I usually see this. This article went far and wide, and it is great work by the people doing it, obviously, but it is already right now, as a disclaimer, quite outdated in a lot of senses. So we can't really use this blindly anymore because a lot of things have changed, and it's not as simple as this image makes it seem also. And because you see a lot of the projects there might be, because there's also different ways to measuring different programming languages. And also, if you write really bad code in a really good, environmentally good language, you're probably going to do worse your job than if you write really good code with a worse language, so to say. So it really has actually the best impact, as I said in the beginning, if you actually optimize and you do smart things rather than blindly, go for something that might seem green. But then this kind of ties into the greenwashing topic as well. But it is a study that might have some interesting merits and whatnot. But I do recommend not to just like run out of here immediately and start, doing Rust development because Annie said so. No, don't do that. Think about the impact, and also if you do languages that you know really well, that's probably the best one. Then hopping on more, so you can also optimize your database. So choosing your database well to begin with, because then the energy used to run the database as well as the idle time waiting for the queries to complete is reduced. Ensure that you're using the best database for interacting with your dataset. And if there's no easy solution, you can use redundant copies. Using index if your database offers it as well. And evaluate and optimize your queries as well. And consider using database cache. Caching can reduce the redundant copies to the database and decrease energy uses by the database as well. So there's a lot of things there. Understanding your latency limits is a good one as well. So think about what you actually need for your application. Because I think in the technology and computing industry, there has been a long-standing notion of, the faster, the better, the more performant, the better, which is true for some cases. I'm definitely not taking that away from applications or, anything that needs it. But you have to kind of sometimes stop and think like, does this application need to be the fastest ever? Because you can think about what does it actually need? What is the consumer, the usage expectation, and so forth. Request and response cycle is something that you could think about as well. And then worker processes versus web processes. So consider using worker processes as a lower priority than web processes, because that helps already. And use work processes in a region with lower carbon intensity, which is already we kind of covered through. And then delay worker processes to run when the carbon intensity is at its lowest, which is again an example of that time shifting. So as you can now kind of start maybe hopefully seeing, if you have the principles that I showed before, time shifting, location shifting, you're essentially taking these kind of principles and the bigger high level impacts and applying them to different portions of your operations and everything. And that's going to yield the best result. Then a bit about autoscaling, because that's a great way to kind of really kickstart these things as well. So I'm going to do a bit about Keda. Who here has heard about Keda? Okay, good amount, but still some people who haven't heard about Keda. That's really nice as well. So Keda is a CNCF project. It just graduated like couple weeks ago, a month ago. So it's relatively, well, it's not new anymore. Graduated projects are all very mature and widely used. But since it graduated just a few weeks ago, it's still, newer than Helm or Kubernetes itself or Prometheus or something like that. So what is it then? Well, it really helps with the fact that default Kubernetes scaling is not well suited for event-driven applications. So Keda is event-driven scale controlling that can run inside any Kubernetes cluster, so you can monitor the rate of the events to preemptively actually act before CPU is affected. And you can install it into new and existing clusters, and it provides 30+ built-in scalars, and you can build your own as well. And there's a fun environmental scaler nowadays as well, so trying out that is also makes sense. So I have a quick Keda demo, so scaling .NET Core Worker with Azure Service Bus. And here we have the demo example here. So there we have the order portal, the order processor, order queue, and so forth. And then you can think about this demo. It's essentially for example, a web shop that gets a rush of orders in at a certain time. So then you have to meet the demand because it peaks, and then it obviously demand goes down. So you have to downscale from there. So let's go and find the demo stuff here. Oh, it went back. My computer doesn't want me to do a demo. Well, maybe it knows something. Let's hope that the demo goes nicely then. Then let's go here. There we go. We get the external IP. So before we actually get to the fun part of the demo, we're going to be doing some things here just to add more visibility so we can see actually what's happening in the demo, because the demo itself is going to be very fast. So here we see the order queue length, the size of the queue, as well as like the number of orders that we have coming in. So then we're going to do this here. So we're going to do kubectl get deployments there. And then we're going to do kubectl get bots here. And in here, we essentially see how many order processors are ready at given time. And here we see what the status of them is. So is it creating new ones or not? And then we're going to get soon to the fast part. So we have .NET Run here, where we ask, let's queue some orders. How many do you want? Now, can someone give me a number between 100 and 150? Anyone? What? 1, 2, 3. Perfect. That's a fun one. I like that. 1, 2, 3. There we go. We're going to queue 123 orders. There we go. Orders are coming in. It should be coming quite fast soon. Yes, there we go. Cheese, chips, keyboard shirt, ball, bike, salad. So many orders rushing in. We must now have Keda kicking off to do autoscaling up. So now we see there the order queue is ramping up, and now we see Keda kicking in. We have 4 out of 4 already ready, and then that's kind of cover a bit of things. Let's actually hope that it goes away. Okay, well, let's maybe do this. There we go. So we see here we have 4 out of 8, 5 out of 8 ready. We are pending, we're container creating, we are running. We are 8 out of 8 currently. We are actually, as you can see, we're handling the queue really well right now. And we are at 10 out of 10 already, because that's where we usually actually with this demo get the highest. And then we are going down, we're down, we're handling it, as you can see here. There, that's it, see you later, so no new orders are coming in. So we handled that 123 orders really nicely. And we are now still at 10 out of 10 order processors. And we went from, pending and container creating to actually just running them. So quite quick demo, but as you can see, Keda really kicked in nicely, auto scaled up, and it will, and for obviously for environmental impact, it's going to start auto scaling down, which is the important part, not just auto scaling up and leaving it there. But it's going to take a few minutes, so we're not going to sit here and stare at this, that when nothing happens for a couple of minutes. So we saw it kick in there. So then we can go back to the slides itself. Now, in addition to this, which was like pure Keda, there's also nowadays a carbon-aware version of Keda, or like a scaler that you can add on there. It was launched in the latest KubeCon, essentially. And here is the keynote about it. So if you want to kind of more dive deep there, recommend looking at this or trying it out, obviously, yourself. Now, CNCF also has great resources around this topic. So there's a working group or tag around environmental sustainability. So if you want to get, it was started, as you can see here, in 2022 by Max and Leonard there. So it's a great group of people that have, for example, their own Slack chat in the CNCF Slack, for example. So if you have any questions around these things in Kubernetes, they're always happy to help out. And actually, even better, if you want to start contributing back there, there's a whole host of things that need to be done. And I think, as I said in the beginning, the scene is very new, kind of fresh. The Green Software Foundation was only started a few years ago. This working group or whatnot was started only, I guess, a bit more than a year ago. So there's a lot of things that need to be done. Still a lot of the foundational building blocks, or so say, needs to be built, even though that we're starting to get there. For example, the CSI, the specification that I mentioned before, was actually created only last December. That's when it was released. So it's been, well, it's September now, so 9 months only when it was released. And before that, there was no standardized way per se to calculate the green impact of your cloud. Obviously, there was ways to do some things and whatnot, but we're striving towards standardization and processes that everyone can follow easily along and so forth. Because before, you had to do a lot of work yourself to understand these things. So they are an amazing bunch that helps as well. There's also a lot of other tooling. So Cube Green or Green Cube is a project that then focuses on spinning down deployments, so reducing the number of replicas to 0 during hours when they're not being used. So that is a great, simple Kubernetes add-on that you can use as well, that automatically shuts down the resources when you don't need them. They also have a really simple, this kind of calculator. If you don't have the stomachs to start, calculating the specification out or actually diving deeper there, you can see how many CO2 is produced by a pod there. So you can actually put in the calculator your metrics and whatnot and see what happens there. And there's a lot of projects in this space as well. So there's Kepler, which is Kubernetes-based efficient power level exporter. So it uses ePPF to probe energy-related system stats and exports as Prometheus metrics. Then you have the carbon-aware scaling that I mentioned before as well. And Green Software Foundation also has carbon-aware SDK that you can use and tap into there as well. Now, all major cloud providers also have usually this kind of tooling, spreadsheets, different. It kind of looks always a bit different, but that helps you then see what is your cloud. So if you're using AWS or Azure or Google Cloud, then you can see, okay, how much is your cloud compute using? But a bit of a fair warning about these, they are usually quite simplified, potentially, and they might not always show all the things that you might be looking for, because again, things are still being built up. And this is a point where you also have to be really think about, okay, what does your actual application mean and need? Because it's easy to kind of just see fancy graphs and kind of go with it, but it's good to think about these things as well on your side. But all the major cloud providers have a similar. This is an example from the Azure side of things. Yeah, but I think that was kind of a lot of the information. I hope no one is kind of dizzy out there. But I think, obviously, in addition to the great benefit of actually having green software and sustainable compute and so forth, there's usually, and these studies have shown that adapting these practices doesn't just lead to those, it's going to actually lead to organizational improvements. Because usually when organizations, then when they start self-reflecting, they start calculating the impact of their actions, they start optimizing, they usually end up with organizational improvements as well. You usually end up with improved performance. So it's not definitely, as I mentioned before, you just, start slowing down everything, there's no performance or anything. No, it is definitely that you can kind of choose what you need for what application and so forth. And also it actually leads to usually improved performance overall when you think about these things. It usually leads to cost savings as well. And also if you do cost optimization, that will likely actually lead to environmental impact reduction as well, which is great that they kind of go in hand, but not always, but quite often they do. It's going to help you meet your sustainability goals as well, of course. A lot of organizations have them nowadays. And obviously, it's going to help you save the world, which is kind of the topic of this talk, as this superhero cat here is doing as well. But yeah, starting the wrap up. So essentially, we went through an introduction. We went through principles of green software. We went through the principle in practices with the microservices example. We went through Keda, and then now we're going through some of the resources as well. So as always, I will have all of my slides and materials in my GitHub, so you can check them out there. I will add this version of the talk today. There's an old version already, so if you're really, really in a hurry to get them, you can even right now go there, and there's an older version of these. There's also a great number of resources that I highly recommend everyone to check out. So Green Software Foundation has a lot of resources. So as I mentioned before, they have everything from a podcast, which is so much information that I actually have to tell you, you can't even consume all of it. But I think that's a bit of a positive thing as well, because you have a lot of options. And as I mentioned, the environmental sustainability tag also has a lot of things. And if you are interested in contributing, they actually had a KubeCon talk, how to get involved in CNCF environmental sustainability tag. So that's a great 30 minutes to kick off if you want to start contributing there. They're also building best practices just for Kubernetes, because most of the best practices around are usually general, but they are building Kubernetes best practices. But that is still work in progress. So if you want it to happen faster, contribution is the key, or you can wait a bit and see when they develop them as well, of course. Then a few more resources. If you're interested in the greenwashing side of things, KCD Zurich, Max gave a talk about greenwashing there. So that's a good one to check out if you're interested in the dark side of things. There's a plenty of good ones. There's a sustainability journey with Keda Obsession, using KubeCreen with Argo CD, carbon aware Kubernetes, as well as green software patterns, and so many that you can dive deeper there. But that's it, I think, from my side. Thank you so much, everyone, for listening, and I hope everyone learned something today.